welcome back. Here is Ali Talabi, and this is lesson 5 from module 20, risk management. So I promised that I'm going to talk about option pricing model. So in this session, we'll talk about binomial model, and the following lesson, lesson 6, we'll talk about Black-Scholes model. So let's start our session. So to explain this binomial model, it is much better to use an example. And for sure, we call this binomial because we just assume two possible scenarios or two possible situations that might happen. For example, let's assume the stock price currently is $100, and we are assuming also the stock doesn't pay any dividend. Now, in one period, this one period might be 6 months or 1 year, the stock price either goes up or down. So if it goes up, we'll say the stock will become S times U. If it goes down, we say that the stock price will become S times D. Now, let's assume that increase is 10%. So in other words, U is 1.1, which means the stock price will be 110. And let's assume the down factor, or D here in this case, is 95% or 0.95, which means the stock price 1 year from now, it becomes $95. So again, we have two possible scenarios. The stock price goes up to 110, or it goes down to $95. And also, let's assume the risk-free rate is 3%. The strike or exercise price is also $100. In reality, we know that there might be for sure more than two possible scenarios, but this is one of the limitations of binomial model, in which we will just we imagine just two possible situations. Now, based on these given scenarios, let's see what's going to happen to the option price. So given the stock we discussed, we are going to construct a portfolio. And our portfolio has two assets. One is the stock itself, another is the call option. To be more specific, we are buying a portion of the stock, and let's call that portion of the stock delta. So it's delta of S. So if S is your stock, you are buying a portion of that stock, which is delta. For example, your delta might be 50%, 0.5, so you are buying 50% of the share. And the second asset here is the call option. You are writing, be careful here, we talk about options, you're writing or you're selling the call option. In this case, you will receive the premium because you are the writer or seller of the call option. So for the second case, for the call option, you receive the premium. For the first portion of the portfolio, which is buying the shares or a portion of the share, actually you have to pay for that stock. So the difference will become delta S minus C. That's the amount you have to borrow. C, that's the premium you receive. Again, delta S, that's the money you have to pay for the specific stock. Now, the question here is, what is the value of this portfolio which you just formed now and also at expiry date? So let's talk about the value of this portfolio. So we talk about two possible scenarios. Either the price is going up or down. So the current value of the portfolio is clear. That's delta S minus C. So that's the portfolio value today. But 1 year from now, or one period from now, if the price goes up, the value of your portfolio becomes delta S U minus CU. If it goes down, the value of the portfolio becomes delta S D minus CD. And be careful here, you are writing the call. So as the price of the stock is going up, remember that you will lose more money because you are writing you are selling the right to buy the stock. So the option holder most probably will exercise the option to buy at the lower price because the stock now is higher, so the strike or exercise price is lower, so you will lose more. That's why you are saying minus CU or minus CD. So anyway, you want just to have lower stock price. That's why you are actually writing or selling the call option. So this is the value of the portfolio at expiry under two possible scenarios. Let's assume your goal here is to construct a risk-free portfolio. In other words, no matter what, if the stock price goes up or if the stock price goes down, you want to have the same outcome or output for the return, for the proceeds of your investment. So in other words, your delta SU minus CU when the price is going up should be same as delta SD minus CD when the stock price is going down. So if you rearrange the formula, you can find the delta from this. So you see here that from this equation, I'm getting the delta CU minus CD divided by SU minus SD. Now, what was the SCU? CU was the value or intrinsic value of the call option when the stock price is going up. So this stock price was sitting at 110 and the strike price was $100. So we can say that 110 minus 100, that's $10. That's how I got CU here. So this is my CU, the value of the call option when the stock price is going up. What about the CD? For sure, when the stock price goes down to $95, the option holder doesn't exercise the option, so the value or the intrinsic value of that option actually is zero. Again, I'm talking about the intrinsic value, not just the option price, because the option price still might be positive, but the intrinsic value is zero. And we know that another component here is the time value. Anyway, what is the stock price when it goes up? 110. What is the stock price when it goes down? $95. So from here, you can calculate the delta, which is 2 over 3. So we need that delta. We'll talk more about the delta later, but that's a first step just to find the delta, which are for our case is 2 over 3 or 0.67. So we talk about the current value of the portfolio, and we notice the current value of the portfolio is delta S minus C. So 1 year from now, given the risk-free rate, the value of the portfolio should be delta S minus C times 1 plus R. That's a very simple time value of money equation. Now, we already talked about the time value of the portfolio at expiry date based on the delta S and U and delta S and D. So we can say that these two should be same because the doesn't matter what equation you are using at expiry date, they should give you the same number. So here is the value of the portfolio 1 year from now, and here is the value of the portfolio where we talk about delta S U minus CU, or you can use delta S D minus C. It doesn't matter which one you are using because we just learned that these two parts, delta SU minus CU and delta SD minus CD, are same because you created a risk-free portfolio. Now, you can use this equation and you can rearrange this equation to find the C or value of the call option. So these steps that you see here are just rearranging this original equation, which I mentioned here. And based on that, you can calculate the value of the call option based on delta S, R, U, CU, and R. And you have all these components. We just calculated delta, which was 2 over 3. You have the risk-free rate, which is 3%. You have the U, which was 1.1. You have CU, which was $10. Now, if you plug all these numbers, you can calculate the value of the call option. So let's do this. So I'm just plugging the numbers. So I will talk about, so this is your delta, 2 over 3. This is the value of the stock, $100. This is your R, which is 3%. This is the U, which was 1.1. This is the value of the call option, $10. And again, this is the risk-free rate. If you plug the numbers, you can find the value of the call option for this example, which is $5.18, and this is per stock. The value of the option per stock. And usually when we talk about the options, we will talk about the bundle of 100 shares, but remember, this is just about one share and the right of buying or selling one share. Here is call option, so that's the right to buy. Now, maybe you say, Ali, what about the put option? For the put option, if you're talking about the same underlying asset with the same exercise price, for sure you can use the put call parity. We learned in the previous lesson that how we can use the put call parity to find the call price from the put price or put price from the call. So I'm just reminding the formula for the put call parity, and from here you can find the value of the put option or the option premium for the put. And if you just plug the numbers, we already just calculated the call value $5.18. That's the stock price. This is the exercise price, and this is 1 plus R. And you can find the value of your put option, which is $2.27. Before wrapping up this session, let me talk a little bit more about delta. We already talked about the delta, and we noticed that's a portion of the stock which you're adding to your portfolio. But actually, delta is more than that. Delta is the risk-free hedge ratio which you are using in your portfolio. More specifically, that's a fractional share amount which is needed to hedge one call option. And remember that you are selling a call option, so you just want to hedge yourselves against any increase in the price. That's why it's important to you that what portion of the share you have to add to your portfolio, because we know that it's not just one stock. So for each call option, it's not just, okay, I'm selling one call option, so I should buy one share. It's not the case anymore, because we know the fluctuation, the volatility of the share and the volatility of the options are not the same. Options are much more volatile. So for one option, you need to have actually less share. But how much less share? That's the role of delta. And you can use the delta for that. In the next lesson, when it comes to Black-Scholes model, we'll come back to delta again, and you will see that the stock price and the option price are associated. The movement of the stock price is associated with the movement of the option price, and how it is determined based on the delta, as you guess. So we'll talk more about the delta. It's a very important concept in the world of options. But that's it for today. Thank you very much. Have a wonderful day. Talk to you soon regarding the second approach, which is the Black-Scholes model.